Okay, hello friends. Here we are. If you can believe it, it is time to review. Once again, we have finished Chapter 9. And so here's the Chapter 9 Practice Test, page 644. You're just going to do 1 through 8, 12 through 18 all. I've cam scanned and uploaded the answer to all of them so you can find them. Notice we're missing a couple in the middle because we did not cover 8.4 and you will not be tested on that. Okay, so I'm just going to go over a good number of these problems just to kind of review Chapter 9. We have our quiz on Monday, and then we'll be having our test later next week. So let's go ahead and jump right in. Number 1 is saying that the height of a triangle in which, and then they give us the area, the base, and they say find the height. Okay, so we have a triangle. So let's just remember what that formula is. It is area of a triangle is 1/2 base times height. Now this is one of those maybe tricky problems where you're not just plugging things in and solving for the area, because they actually give you the area and we have to go back and find one of the missing dimensions. Made a little more complicated by the fact that they are not even giving us a whole answer, they're giving us an answer with variables. But if we take our time, we can see that that's not too difficult. So if I fill this in, we have our area, which is 12x squared y. We replace our a with that. 12x squared y equals, we still have the 1/2 times we have a base. Our base is 3x, and then our height is what we don't know. So now we simply need to divide or reverse the multiplication process and get h by itself. Seeing all these variables, our answer will be with variables in it. It will not be like 5 meters squared or something like that, or feet squared. So here we go. So how do I do the opposite of multiplying by a half? You either think of dividing by a half, or that's the same as multiplying by 2. So I'm going to multiply both sides by 2, and so that's going to cancel out the half. This is going to become 24x squared y equals now 3x h. So we doubled this side because that's the opposite of cutting it in half, which is what you do with a triangle formula. Now we need to get h by itself, so we're going to go ahead and divide by what's left, 3x. So divide both sides by 3x. Okay, so that cancels out. Also, a little bit of an algebra review. X squared divided by x, that means you cancel out one of the x's. And then you reduce this fraction, 24 divided by 3 is 8. So what we get is we get 8. It's like reducing fractions. There is now, this x is gone, but there were 2 up here, but now there's 1 left. So 8xy equals h. And so I have h by itself, so that means the base, the height in this example was 8xy. And then I could add feet squared to have units, not be naked. So 8xy. So 2 things that make this a little complicated. 1, we're solving backwards. 2, we have to work with these variables. But that's a good algebra review, thinking ahead to algebra 2. So 8xy, and I could check this because I could take 8xy and I could multiply it by my height, or my base, 3x, and then kind of reverse the formula. So you could know if you got this right or not by taking your answer and remultiplying it. 8 times 3 is 24, cut in half is 12. X times x is x squared, and y. And so my area should be 12x squared y, which in fact, that's what it told me. So I know this is the right height. All right, number 2, a similar problem, but this time we're not going to have to deal with the x and the y, but we're given a trapezoid, and we're given the area, a height, and a base, and we have to find the other base. So, same way, I'm going to start with the formula. So the area of a trapezoid is 1/2 base 1 plus base 2 times the height. And once again, we can simply plug in what they've given us and solve for what's missing. So the area is 161.5 equals 1/2 times, and we have one of the bases. One of the bases is 13, and then we don't know the other base. And then our height is 17. So same exact problem, except now we don't have the variables to work our way through. So start again, first of all, with the half. So I'm going to multiply both sides by 2. Multiply both sides by 2. That's going to give me, cancel that out. This comes out to 323 equals 13 plus b times 17. So now the timesing, we want to undo that because we always work in reverse order. So dividing by 17, both sides. That's going to cancel out. And so then we're left with 19. You can use your calculator. I'm not doing that in my head. 19 equals 13 plus b. So something plus b is 19. You can see what it is, or again, you can just algebraically finish the problem. Minus 13 on both sides, opposite of adding. And so we get, or I don't want to bleed into my next problem, so I'm going to put it over here. We get 6 equals b. All right, and again, go back, check our units, 6 centimeters squared. Well, actually, this would be 6 centimeters because it's a base. Just like actually this would not be squared either. Okay, so 6 centimeters. And again, I'm not going to take the time to do it, but you could plug it in, and we could do it mentally really quick. 6 plus 13 is 19. 19 times 17 is 323. Cut in half would give me the area of 161.5 that I started with. So I can know for sure, if I take the time to check it, that 6 is the correct second base. Okay, number 5. I think maybe one of the trickier things. Hopefully you're working on polygons. But again, it takes a little bit of work to find all the dimensions, but you can do it. It's an important skill to develop in math. So we have a hexagon, so a 6-sided shape, and the length is 14 meters. And so just to review the strategy here is our area formula is 1/2 times the apothem times the perimeter. The apothem being the center point that goes perpendicular to the middle of a side. And the way to find that is to calculate, look at a right triangle here, using the side we know, using the internal angles that we can easily calculate because they're evenly split among 360. We can solve for the height of this triangle, which will be my apothem. My perimeter is easy. I got 14 on this side, and I have that 6 times. So I've got the perimeter. The work is going in to find the height or the apothem of this little triangle. So what I like to do is I like to redraw that triangle nice and big. I don't even draw this when I solve these once you get good at them. And I say, okay, I've got my right triangle. And again, this is just a zoomed in on this. So I know what this base is. It's not the full 14, it's half of it. So this is 7. Okay, what's this angle? Well, we've got 360 degrees divided by 6, and that would be, let's see, I'm checking my note, 360 degrees divided by 6, that's 60. So the large triangle here would be 60, and this is half of that, so that means this angle is 30 degrees. And so now, and what we just, I'll summarize, we did 360 divided by 6, which gave me 60 degrees, and then you cut that in half because this little triangle is only half of the larger pizza slice, and so that's where we get our 30 degrees from. Okay? And so now we have this triangle. So now I can use SOHCAHTOA, tangent, opposite over adjacent, because I'm solving for my apothem here. Tangent of 30 equals 7 over a, and I can solve it that way. So go ahead and do that if you want. However, this is also a special triangle, and I encourage you to work with those because they save a lot of time. In a 30, this must be 60, 90-degree triangle. If I know the short edge, I know that this height is a quick ratio of that. In fact, it's this number times the square root of 3. So without even doing SOHCAHTOA, which you can do if you don't know this, so that's fine. But I know that this is 7, the square root of 3. So I can immediately know my apothem once I see that this is a special triangle. It doesn't require actual calculations. So now I have my apothem. Boom. Let's plug this in. The area is 1/2 times my apothem, 7 square root 3, times the perimeter, which is going to be, nope, not 7. Watch out. The full side is 14. So that's a perfect example of a mistake you could make. 14 times how many sides? 6. Because 6 times 14 is my perimeter, and then 7 root 3 is what I found to be this apothem here. So go ahead and crunch those numbers. Because there's a radical in it, I'm not going to, well, why not? I'll just show you. I'm here for all things as best I can. All right, so we're going to go, let's just start with the 7 square root 3 equals that, times 14 times 6. And then now we need to divide by 2 because I'm multiplying it by 1/2. So divide by 2, and I get 509.2, which is in fact correct. 509 area equals 509.2. It says, I think, to round to the nearest tenth. So we do. Actually, yeah, round to the nearest tenth. 509.2 meters squared. So there she is. So practice those. That's 9.3. or actually I think it's 9.2, sorry, 9.2, with the whole process of 1/2 apothem times perimeter, and then using this cutout triangle to find that apothem. And you will have other problems where maybe they give you the apothem and you need the side length, but it's the same process, but in reverse. You're finding this side instead of that side. Okay, let's go on to number 6. Number 6 is one of our composite areas where, again, you're finding the shape of kind of an irregularly shaped item by looking for similar or simpler shapes within that. And so I need to find the area of this shaded region, which I can see is basically a rectangle with some pieces cut out. So if I find the area of the rectangle, and then I can find the area of this triangle, and the area of the semicircle, I can find the shaded region. I think that's at least my tactic. So first, let's go ahead and find the rectangle. The rectangle is simply base times height. So I'm going to go ahead and go area equals base times height. So 15 times 8. 15 times 8 is my area, and 15 times 8 is 120. So we have 120 equals the area, the total area. Now, so my answer is going to be less than that because I got to subtract this triangle and this semicircle. Okay, so we've got the triangle. Luckily, the dimensions of all these are pretty straightforward, so we can solve them. Area of a triangle, 1/2 base height. Okay, the base is 6, the height is 8, so that's 1/2 times 8 times 6. 8 times 6 is 48. If we cut that in half, it is 24. So the area, one piece being subtracted, is going to be 24. And then we need to go ahead and find our semicircle, okay, which is just going to be half of a circle. Now the area of a circle is area equals pi r squared. Now if you look at this circle, you might think, well, how do I know r? Well, r is halfway. That would be the radius. And I know the whole way across, which is the diameter of this circle, I know that it is 8. So this is 8, and so I know the radius of this circle must be r. So pi 4 squared is going to be my area. So that's 16 pi, and 16 times pi is 25.12. So that's the area of the complete circle. Now don't forget, this is only a half circle. So I need to cut that number in half. I need to divide it by 2. And so my ultimate area that I need to subtract is half of that, which is, oh, actually, I'm sorry, I jumped ahead. Let's go ahead and check it. I think I'm looking at my notes. So here we go. We got 16 times pi, 50.2. That's right. So the full area is 50.3 actually, and then that's what I want to divide by 2, and so 25.1 is actually my 25.1 is the area of the semicircle. So sorry, I was skipping the calculation there. So to review, we have the full rectangle at 120, we have a triangle at 24, and we have a semicircle at 25.1. So all the math that's left to do is to just do 120 minus 24 minus 25.1. We'll go ahead and calculate it. 120 minus 24 minus 25.1, and we get 70.9, which, at least according to the book, my calculations is correct. So we get 70.9, check our units, centimeters squared. So here's the 3 types of area we're dealing with. Basic area, though a lot of times solving backwards, having already known the area. Regular polygons, using 1/2 AP, and then irregular polygons. All right, but we're going to go ahead and continue with a few more on another sheet of paper. Because I know you're enjoying this. Again, pause me, cut me off, rewind, fast forward, whatever works for you. I'm here to serve. Number 8, another irregular polygon. They've given us this blob here. And this is where we need to find the area by dividing it up into shapes that we can calculate. And again, you can kind of do this practically by just counting the squares, and you can see how that works for you. But I'm going to show you the dividing up way and see how we do. So first, I'm going to look for shapes that I recognize. Okay, I'm going to be pretty conservative here. I think I see a triangle. I think I see a parallelogram. There is a trapezoid right here. And then we kind of get this funny shape here. And I'm going to go ahead and divide that into two. Looking at the picture, I'm going to divide that into, let's see, what would be the best way to do this? Let's go with a triangle, because the way it actually looks, it looks like a pretty clean triangle there, and then a trapezoid here. So I'm going to, kind of a complicated way to do it, but just want to demonstrate how you can do that. On a multiple choice test, you might be able to count them and get closer. Whatever works. In math, whatever works. Though some ways are easier than others. All right, so the triangle, let's start with that. 1/2 base height. The base is 2. The height is 1. So 1/2, 1 times 2. And so I can see that the area for the triangle is, 2 times 1 and half is just 1. Okay? Then I'm going to go ahead and find the area of this parallelogram. Parallelograms are base times height. The base I've counted is 1, 2, and the height is 1, so just 2 times 1. So the area of my second shape is 2. Okay, so this is 1, this is 2. Now I've got a trapezoid. Trapezoid, I add the bases, multiply by the height, and cut in half. So I've got one base of 2, for the other base of 4. So I've got 1/2 times 2 plus 4 times a height. All the heights are 1, so it's pretty simple. So we got 6 divided by 2. So I'm going to get an area there of 3. Okay, now we've got a triangle right here. This triangle is 1, 2, 3 on the base times 1 height and then times a half. And so I'm going to get 3 times a half. So that I'm going to get there an area of 1.5. And then this other trapezoid, again, add the bases, multiply by the height, a base of 1. Plus another base of 2, a height of 1, and then times a half. Okay, hopefully you're getting good at these formulas. I'm going a little fast here, but I have a base of 1, base of 2, height of 1, and you cut all that in half. So we get 3 times 1 divided by, so this is also 1 and a half. And so let's go ahead and add these up. 1, 2, 3, 4, 5, 6, and then these two together are 1 and a half, so I'm going to get 9. 9 yards squared. Calculating another different way, I got 8.5. The book says 8. So if you're following along, you're checking your answer sheet, the book says 8. I purposely did it this way because with a problem like this, I'm going to make sure that the multiple choice answers aren't even close. Or, not within, I think, a margin of error, because I think this is a pretty good way to calculate it. I think even if you count the boxes, you get 8.5. And so I'm saying 9. The book says 8 yards. On a test, the margin of error will be within those two numbers, so you don't have to worry about that. Just remember to divide it up in areas you can identify and get as close as you can. It is, in fact, an estimate. I think that's an okay estimate. Alrighty, so I want to make that point. We're just going to do 3 more, but they're going to go pretty quick. Number 14, this is about scaling dimensions. And so there's really no work. I'm just going to read it. It says, and again, they give you lots of information on 14, but notice I want to show you how simple of a problem it is. It says there's a circular garden and the diameter is 21 feet. Janelle's planning a new circular plot with an area 1/9 as large. So notice the area is being reduced by, let's just say 1/9. Okay, the area is being reduced by 1/9. And so then they want to know what the circumference of the new plot will be. Okay, so what you're doing is you're going from a squared value of area to circumference, which is the same as dimensions. That what we learned is that if you scale a side length or a circumference or perimeter, then you can just multiply by that number. If you scale an area, then you need to multiply by that number squared. Okay, and then we also learned then if you're going to go in the reverse direction from area to a linear side or perimeter, which circumference is, how do you go from a squared to a? You need to square root it. So this is saying if you make a 1/9 change to the area, what will it do to the circumference? Well, it's going to do, you just need to square root it. If you're starting with the circumference or starting with a side to the area, we've learned you square that. If you're going in the opposite direction, you're going to square root it. And so the effect on the circumference is going to be the square root of 1/9, which is just the square root of 1 is 1, the square root of 9 is 3. And so the circumference will be 1/3 of the old circumference. Okay? Just remember, if you're going from area to non-area, square root it. If you're going from non-area, perimeter, or side length, square it if you're going to area. Okay? And so they gave us the 1/9 of the area, so now we've square rooted that. It's going to be a change of 1/3. All right, lots of problems with number 16, the next 15, 16, 17, but I just picked out 16 as an example. It says, find the probability that a point will land not on QR. So not on QR. So that means what's the probability of not being here? Well, that would mean RS and NQ. And so probability is simply the actual occurrence over the overall possible occurrence. And so we can see this line has an overall possible occurrence, whatever these numbers represent. 12 plus 8 is 20. 20 plus 6 is 16. 20 plus 6 is 26. So the total possible is 26. And if I'm trying not to hit QR, then I'm hitting either 12 or 8, which is then 20. So I can express this as a simplified fraction. That's 10 over 13. Which is what they give you in the book. Or if you like to put that as a percentage chance, then we go ahead and go 10 divided by 13, and that is a 77% chance of not hitting, because I got 0.77, a 77% chance of not hitting QR. Okay, which again makes sense because you can see there's a lot of available area, so it's a pretty high percentage, a good opportunity, 10 out of 13 tries. That's what that basically means. Okay, and the last one, number 18. Shuttle bus for a festival stops the parking lot once every 18 minutes and stays at the lot for 2 minutes. What are the chances, if you go randomly, that the shuttle will be there when you arrive? Okay, so again, you've got, and I can draw this, but I'm just going to explain it. Well, I'll draw it in case it helps you. You've got an overall possible time period of 18 minutes. Now, not on top of that, that's not when the shuttle isn't there. Overall cycle is 18 minutes. It's in there within those 18 minutes. And so for two of those minutes, this is when the shuttle is present. So you can see this is a very simple problem. They didn't ask it very complicated, like, oh, what's the probability you'll have to wait less than 3 minutes for the shuttle or whatever. We can do that. This is an even easier one. What's the probability that you hit this point? That you hit the 2 minutes out of the 18 when the shuttle's there? Well, you just said it. The 2 minutes that we're looking for out of the overall possible of 18, it's 1/9. Okay, 1/9, and if I crunch that on my calculator because I like percents, I have a just over 10% chance at 11%. 1/9 or 11%. Okay? Just remember, if they'd asked a more complicated version, which could show up, like say, what's the probability you won't have to wait more than 5 minutes? People don't want to wait more than 5 minutes. Well, then that would just increase the target zone beyond my 2 minutes to an extra 5 minutes. And then I could see that, well, now I have a target zone not of 2, but of 7 minutes. There's 7 minutes that are good where either the shuttle's there or I'm only waiting 5 minutes. And so I could just change this fraction. Now I have a target zone of 7 over 18. So you can do a more complicated version, and we might see those in the chapter review. But this one is pretty straightforward. I have a target zone of 2 out of a possible 18 minutes of waiting. Okay, so that is the Chapter 9 practice test. It went over a lot of it, but it's a good chance to see what do you remember, what is the hardest section, what do you want to most review. First, we'll be having a quiz, and then we'll be taking the full-on test of all sections. So good luck. Again, please contact me Friday, Monday, anytime for help. If you're not getting this, I encourage you to finish strong these last couple weeks because you can do it, and I'm here to help.